Margaret, a library assistant at the Lincoln Public Library, and welcome to Hangout. This week's theme for Hangout is Let's Experiment with Food. So in this week's episode, we're going to learn how to do the tablecloth trick. That is where you whip a tablecloth out from underneath some dishes. We are going to make ice cream out of bananas. And we're going to use some cream to make butter. For the tablecloth experiment, you'll need a cloth, preferably a piece of material that has no hems or seams, and preferably nice and smooth. You will need a plastic plate, plastic cup, and a knife and fork. For the tablecloth trick, place the material over the table, grasp the material, and pull it down quickly. So the same thing with the cup, place material on, put the cup onto the table, grasp the material, and then pull it down quickly. Same thing with the plate, the cup, knife and fork, grasp material, and pull it down quickly. And I recommend to practice this a few times. It doesn't always work the first time. That's why I recommend it. So how the tablecloth trick works, all thanks to Sir Isaac Newton. His theories help us explain why this trick works. The key is inertia. The principle of inertia states that an object at rest, one that isn't moving, for example the plates, stay at rest unless another force acts on that object. In this case, the plates stay at rest because the force of you pulling down on the tablecloth isn't enough to move them. The principle of inertia also says that if an object is moving, it will keep moving unless another force acts on that object. Imagine you're in a car, you and the car are both moving. If the car slows down gradually, you slow down too. The friction of your body against the seat and other forces combine to help you slow down. If the car stops suddenly, inertia will keep you moving forward. This is why you need to wear a seatbelt. Your seatbelt prevents you from moving forward too far when a car stops suddenly. So just to recap the experiment, according to Sir Isaac Newton's law of motion, 1, an object will remain at rest until a force acts on it, and 2, an object in motion will remain in motion unless a force acts on it. Thus, our full table setting, the plate, the cup, and the silverware will remain in place at rest unless a significant force acts on them. Where does friction come into play? Well, initially all the objects are at rest, not moving. When you pull the cloth, friction acts on the objects in the direction of the pull for a short time. But the tablecloth with no hem or edging is slippery, so these forces are small and the cloth comes out from underneath the objects. So I just poured my cream into my container. Now I'm going to put the lid on it And this is when you need to use your elbow grease. And now it's time to shake. So after 2 minutes of shaking, I now have butter. And the liquid is buttermilk, and you can drink this or use this in recipes. So there you have it, butter. So how does the butter experiment work? What is the science behind making butter? Well, when you're shaking the fresh cream, the fat molecules in the cream get shaken out of position and clump together. Eventually, after enough agitation or shaking, the fat molecules that are clumped so much forms butter. During this process, the fat molecules get separated from the liquid in the cream, and the liquid is called buttermilk and can be removed. Why does shaking cream make butter? Well, cream is nothing but the milk fat. A complex mixture of lipids gets stabilized by its own fat molecules. When the cream is stirred up, the fat molecules all together form a clump, leaving the water molecules, since fat does not like water. Does heavy cream turn into butter? Yes, heavy cream absolutely can turn into butter. When the cream is agitated, the fat molecules get shaken out of position and clump together, forming butter. How does the butter experiment work? Is making butter a chemical change? Yes, it is a chemical change. The cream goes through a physical change when it is churned into butter. The fat molecules clump together while stirring and shaking, causing the liquid water molecules to be squeezed out of the solid mass, which is butter. This physical change is absolutely reversible. The butter can be melted and mixed with buttermilk to make cream again. Our next experiment will be making banana ice cream. And how do you make banana ice cream? You need roughly 3 frozen bananas. We have some frozen berries, 1 cup, and coconut cream. We're going to need about half a cup of coconut cream, 1 teaspoon of vanilla, and some sugar. So I put in the frozen bananas. The coconut cream, and the frozen berries. We just need a teaspoon of vanilla. And a couple of teaspoons of sugar. And about 2 teaspoons of sugar. Now we're ready to mix it up with the blender. Just going to get a scraper, just make sure that it's all mixed up. Take off some of the excess here. Make sure all my bananas, just going to go through one more time. Okay. And there you have it. It looks like soft serve berry ice cream. And this is my soft serve ice cream. So the banana ice cream recipe recap. What you need is 3 bananas, halved, placed in freezer bags and frozen overnight. 1 cup of frozen fruit, I just used mixed berries. Half a cup of coconut cream. 1 teaspoon of vanilla, and I did use 2 teaspoons of sugar, and you need some kind of a blender or food processor. So how to make the banana ice cream? Just after a few minutes in the food processor or with the blender, it takes about 2 minutes. The ingredients do really have the texture and temperature of a soft serve ice cream without using any milk or cream. The reason is because of the banana. The bananas have high levels of pectin, which is a type of water-soluble fiber. But there's something that happens when you freeze the bananas, and it breaks up that fiber when you put it through the processor, and it makes for a great fake ice cream.